Hello, my name is Sam Blair and I'm a master's student here at Iowa State with Dr. Danny Singh. We can fly a 20-acre field in under an hour and get the same information at a high resolution. And the reason that relative maturity is so important is because it allows a farmer to take advantage of the most amount of growing season they can without running into issues of frost in the spring or the fall. And so because of this, breeding companies will spend a lot of time collecting this information on each new soybean variety to make decisions on which cultivars to release and in what regions to release the cultivars. So the way currently that relative maturity data is collected on new soybean varieties is by having workers go out into the field and manually take notes on each new soybean variety in the field. And then in any given year, there could be anywhere from thousands to tens of thousands of plots to take notes on. And as you can imagine, that would take a lot of time. It takes a lot of workers, a lot of hours, a lot of days for several weeks to collect all this information. So the first step of this project is to take a drone, and we fit that drone with a RGB camera, which is just a normal camera like your phone would have. And we take this drone and we fly it up to about 60 meters. We have preset into the drone a flight path to follow the field. It's kind of a serpentine pattern, and it'll go over the entire field, taking an image about every second. And so for a 20-acre field, we may get about 1,100 photos. And we'll do these flights about 3 times a week, starting from when the earliest new soybean line is fully mature to when the latest soybean lines mature. So after each flight is taken, we'll take these images and we'll use a computer program to stitch all of the images into one large high-resolution photo of the entire field. So we go from 1,300 or so images to one very large high-resolution image. And after this, we'll use a program to make boxes around each of the plots. And so for a 20-acre field, there may be around 11,000 plots. And so after the boxes are made around each new soybean variety, we extract from this box a photo. So each new soybean variety becomes its own photo for each time point. And so after that data is collected, it's given to the computer scientists and used to train the models to make the automatic soybean maturity ratings.
Hi, I'm Shivani Chiranjeevi from Mechanical Engineering Department. I'm doing my PhD with Dr. Baskar, Ganapathysubramanian and Dr. Arti Singh. I like using AI and automation tools for plant science-based applications. So we have these plot images of the soybean crop with their corresponding human collected maturity rating, and we would be training an ML model on top of this. So we train multiple such ML models with, and that would essentially connect the human collected data with the drone-based images to output the maturity rating. And we would choose the model which has the best accuracy. Once you're done with the training phase, then comes the validation phase where you'd be testing the model with unseen data. So we would use many independent images with no maturity rating, and we would use the model to predict the maturity rating, and this would give you an approximate estimate of how well your model would perform in real-time applications. Once you're done with this, the breeder could use the best model to predict the maturity rating. That's the goal of this project.
So a process that would normally take upwards of 120 man-hours, we're hoping to whittle down to under 10 man-hours. And ultimately the goal is to give breeding companies a new way to collect their information to save time and give more accurate breeding decision data.